Okay, it's time to review module. What do we got here? Topic 3. All right, easy enough. Here we go. Number 1, consider the logarithmic equation log base 25 of 125 equals n. This is a question that's just making sure you know your vocabulary. The argument is 125 in this problem. That's what the argument is. It's always the number that's right there. The base is always tiny, right? So that is 25, and the exponent would be n. So if we rewrite the equation in exponential form, then we would write it as 25, which is the base, to the n power would equal 125. Now the next part says solve the equation. The way I would solve this, I notice these are both bases. These can be written as a base of 5. So let's just do that down here, 25. I'm going to solve this 2 ways actually. So here's the first way that I would solve it. I would say that this is 5 squared, and that is being raised to the n power. And I know that this 125, that is 5 to the 3rd power, right? So now I can multiply those exponents. We're going to get 5 to the 2n equals 5 to the 3rd power. And I know that if the bases are equal, then the exponents must be equal. So I can go 2n equals 3. That's because of the exponents. And then I divide by 2, I can get n equals 3 over 2. That is one way to do it. Let's write that down, 3 over 2. Or you could say a half, 1.5, right? So that's equal to 1.5. Either of those is fine. What is a different way to solve this problem? Well, a different way to solve this problem is to use logs. So, all right, what am I going to do? Log of 125. We could just take the log of this side here, and we could take the log of this side. And when we do that, we could bring that n down because that's a rule, right? So we're going to get n times the log of 25 would equal the log of 125. And then we could divide both sides by the log of 25. Let's get the calculator out so we can see what that would look like. Okay, so we have the log of 125 divided by the log of 25. We put that in the calculator. We again get 1.5. So you could do it either way. I like the red way because we're K-Town. Number 2, suppose log A of 3 equals m and log A of 5 equals n and log A of 11 equals p. Rewrite this write an algebraic expression for log base A of 25 over 33. So by now you have experience with these. You can look for these numbers here, 3 and 5 and 11. And we need to make these numbers that are in this fraction or in this expression. And rewriting this, I can easily see that 25 is 5 squared, right? Or 5 times 5. And 33 is actually 3 times 11. So if I were going to rewrite this using my properties for logarithms, I could write this as log base A of 5 squared. And then we're dividing by each one of these, so it's going to be subtraction minus log base A of 3. And then we're going to subtract again because both of these are on the bottom. Minus the log base A of 11. I'm going to take that 2. It's an exponent, bring it down front. We love to do that. So this is going to be 2 times the log base A of 5 minus the log base A of 3, and then minus the log base A of 11. And if I go up and I look at all these, I know that, what do we got here? Log base A of 5 is n, so this becomes 2n minus m, if we substitute, minus p. And that is the expression for number 2. Easy enough. Let's go to 3. We can solve 3 2 different ways. So I'm going to start with, let's do common base again, because they love to make you do common base. What do we get here? This is 2 to some power. Let's check out our powers. We're going to get out that calculator. All right, it's got a lot of stuff on it. Oh, I want to clear everything. Quit. All right, clear. So I'm going to check some powers of 2 here. So what is 2 to the 6th power? And we check that as 64. Hey, I got lucky right there. So 64 is 2 to the 6th power. Okay, and then we're going to raise that to the 2x minus 3. This will all equal. Now what is 512? That's one of those numbers I know. Oh, I know. Do you know that's like a multiple here? Is that 2 to some power? Let's try 2 to the 9th. Boom. That worked out for us. So this is 2 to the 9th. So now I have a common base, and I can write 2. I got to multiply these, right? Don't forget to distribute. to the 12x minus 3, minus 18. I just said, don't forget to distribute. That'll equal 2 to the 9th. Well, the bases are the same, so guess what? Exponents have to be the same. So 12x minus 18 has to equal 9. If I add 18 to each side, I get 12x equals 27. X will equal 27 divided by 12, whatever that is. Guess what I can do? Reduce it, 9 over 4. Okay, what does that equal to? 2.25. All right, that is one way of doing it. Now, if you want, you can choose just to use those good old logarithms here. Let's rewrite this. 2x minus 3 will equal 512. You could take the log base 64 of this side and log base 64 of the right hand side. That will cancel these, right? And we'll be left with 2x minus 3 will equal log base 64 of 512. Then we can add 3, right? This is a regular Algebra 1 equation. Let's add 3 to each side. Now, what students have been doing, big mistake, you can't add 3 to that 512. This is its own thing here. Log base 64 of 512. This is all going to equal log base 64 of 512, and then we just throw a plus 3 at the end of it, okay? Because you have to do that first part first. You got to take that log first. That's what 2x will equal, and then we can just divide by 2. So let's put that all in our calculator. This is a good example because a lot of you have been messing up that calculator. How would we put this in the calculator? Let's look at it. So I'm going to hit the math button. I'm going to go up to base, log base. I want to do log base 64 of 512. So I'm going to put that in, and you know what I'm going to do? I'm just going to hit enter first. And I get 1.5. I will then add the 3. I'm going to hit enter again. That gives me the numerator. And if I divide by 2, do I get that 2.25? I do get that 2.25, okay? For those of you that like doing everything in one step, you could do it like this. You could use parentheses. We could do the log base 64 of 125, or I'm sorry, of 512. We add 3, and then we divide by 2. You just have to make sure you use those parentheses right. Otherwise, you will not get the right answer. There's number 3. All right, number 4, the concentration of the hydrogen ions in lemon juice is about 6.3 times 10 to the negative 3. What is the pH? And remember, here's the formula. We've worked with this formula before. The pH is the negative log of the hydrogen concentration. So really all we need to do is plug this number here into this part right there, that variable, the concentration of hydrogen ions. So let's just do that. Negative log of 6.3. Let's type that in. Times 10 raised to the negative 3. Okay, I'm going to come down. I'm going to end my parentheses. And we get about 2.2. Oh, that is acidic. But it's lemon juice, so that makes sense. 2.2007, we'll say. We'll round that. 2.2007. If the pH level is less than 7, it's acidic. If it's greater, it's alkaline. Is lemon juice acidic or alkaline? Well, obviously it's acidic. That one's easy. Let's go to 5. Consider the following equation. Oh, you guys love these. Solve the equation showing all your work. So you got to show your work for this. Our properties of logs. We can put these together. If we're adding logs, that means we can multiply the arguments here. So this is equal to log base 4. I'm going to multiply these, but I'm just going to write it out without multiplying it, just so we can look at what we're doing here. This all equals 1. Okay, so how do we get rid of a log base 4? We can raise each side of this equation as a power on 4. Okay, so it'll be 4 to this and 4 to this. But I have a different way to think about it. Your book does a great job of thinking about it this way. Let's just rewrite it in exponential form. So that means that the base to the exponent, so 4 to the first, is going to equal the argument here, which is x times x plus 3. So now we can distribute, and guess what? This becomes a quadratic equation. We get x squared plus 3x. I'm going to move that 4 over, so we have a minus 4. That will all equal 0. Now we have to factor it. Woo, so we got to get a negative 4 but a positive 3. That's got to be x plus 4, x minus 1. Right? Check my factoring for me, but I think I'm okay. When I set each of these factors equal to 0, I'm going to get x equals negative 4. I'm going to get x equals positive 1. Now it says check your work and look for extraneous solutions. We know those extraneous solutions. So we're going to plug in the negative 4 first. So log base 4 of x plus 3. Now, when it says check your work, we have to show that we're checking our work. So I'm plugging in the negative 4 plus 3, and then I'll write the rest of it out. Sure. Oh, we're going to have an issue right there, right? So that's a negative argument. This is also a negative argument. Cannot have negative arguments, so that is extraneous. We're going to cross that out, so it's very clear we don't want that one. Now we will check that x equals 1. Okay, so log base 4 of 1 plus 3 has to, if you add it to log base 4 of 1, it should equal 1. Okay, so this is log base 4 of 4. What exponent do I put on 4 to get 4? That's equal to 1. Plus, what exponent do I put on 4 to get 1? 0. That all has to equal 1. We get 1 equals 1. That check works. So our answer here is x equals 1. There you go. That's the review. Good luck. The test should be very similar. This is Mr. Kelly in K-Town. Remember, it's nice to be important. More important to be nice. See you.